Good morning. Hi everybody. How are you all? Hope you doing great. Welcome back to another session of learning mathematics with me. Before beginning, I would like to request please subscribe the channel Tangent Academy. Also like the video and share it with friends too, so that you can get one maths problem or physics problem every day. Now let's begin with today's problem. Today I have taken it from complex number. To find, we have to find argument. Here is the question. If Z1 and Z2, if Z1 and Z2 are two complex numbers, which satisfy Z plus Z bar is equal to twice Z plus Z bar, means conjugate of Z, 2 times Z minus 1. Then, and also one thing more is given, and argument Z1 minus Z bar, Z1 minus Z2, argument of Z1 minus Z2 is given as pi by 4. These two things are given. Z plus Z bar is equal to 2 times Z minus Z1, and argument of Z1 minus Z2 is equal to pi by 4. Then imaginary Z1 plus Z2 is imaginary part of Z1 plus Z2 is given by option 1 minus 3, option 2 3, option 3 2, and option 4 minus 2. We have to select what option is true. That is value of imaginary part of Z1 plus Z2. We have to find. As let us start. As Z1 and Z2 both satisfy Z1 plus Z bar is equal to 2 times Z minus 1, 2 times Z minus 1. Therefore, we can write Z1 plus Z1 bar is equal to 2 times Z1 minus 1, relation 1, and Z2 plus Z2 bar is equal to 2 times Z2 minus 1, relation 2. As in the question given that Z1 and Z2 both will satisfy Z plus Z bar is equal to 2 times Z minus Z1. Therefore, we can write Z1 plus Z1 bar is equal to 2 times Z1 minus 1. Z2 plus Z2 bar is equal to 2 times Z2 minus 1, where Z1, Z2 bar are conjugate of Z1 and Z2 respectively. Now we will put the value of Z1 and Z2. Let us consider. Let Z1 is equal to x1 plus I times y1, where I is the imaginary unit, and Z2 is equal to x2 plus I times yt unit. We know that any complex number can be written in the form of a plus ib when a is the real part and b is the imaginary part. In this context, z1 we can write x1 plus iy1. x1 y1 are imaginary points. z2 is equal to x2 plus iy2, and put these values in the relation obtained in 1 and 2. So in 1 we can get z1 is equal to z1 plus z2 is equal to z1 plus z2 is equal to 2 times z1 minus 1. This implies x1 plus iy1 plus x2 plus z1 bar, x1 minus i1, x1 plus iy1, x1 minus iy1 is equal to 2 times value of z1 put here, x1 plus I of y1 minus 1 minus 1. As we know that where conjugate of a plus ib is a minus ib. So conjugate of x1 plus iy1 will be written as x1 minus iy1, and bar sign symbolize the conjugate of z1 is z1 bar. So z1 bar, the value of z1 bar is x1 minus iy1. Now we will group imaginary part and real part. Twice x1, x1 plus x1 twice x1 minus 2 times iy1, 2 times iy1 not, iy1 positive, iy1 negative will be cancelled out. 2 times ix1 will be equal to 2 times modulus of x1 minus 1. x1 is real, minus 1 is real, so we have grouped as follow: x1 minus 1, and this is imaginary part iy1, and this symbol is known as modulus of this function. So modulus twice 2 cancelled from both sides, so we can write x1 is equal to modulus of x1 minus 1 plus I times y1. So x1 will be written as under root real coefficient square plus imaginary coefficient of square according to the definition of modulus function. Now we will square both sides. x1 square can be written as x1 square minus twice x1 plus 1 plus y1 square, breaking it into the form of a minus b whole square. We can get the similar term from both sides will be cancelled. It can be written as minus twice x1 is equal to 1 minus no, this is transposed, minus 2x1 is transposed in the left hand side. So twice x1 can be written as 1 plus y1 square. Let us denote relation 3. Let us denote it as relation 3. In the similar pattern, if we do same thing in z2 is equal to x2 plus i2, from this relation z2 plus z2 bar is equal to 2 times z2 minus 1. 2 times z2 minus 1 we can get similarly from relation 2, from relation 2 we can get similarly from relation 2 we can get 2 times x2 is equal to 1 plus y2 square. Let us denote as relation 4. Let us denote as relation 4. Now we will subtract relation 3 to relation 4. We are doing here relation 3 minus relation 4. Let us see what are occurring, what are happening. So relation 2, 2 times x1 minus x2, we will get 1 plus y1 square minus 1 plus y2 square. 1 plus y2 square. We can have y1 square minus y2 square. This can be factorized as 2 times x1 minus x2 is equal to y1 plus y2. y1 minus y2. It can be broken into the formula a square minus b square, which will get to you a plus b and a minus b. So we have 2 times x1 minus x2 divided by y1 minus y2 will be equivalent to y1 plus y2. Let us denote it as relation 5. Let us denote it as relation 5. Now we are going to find out z1 minus z2. Now z1 minus z2 is equal to x1 plus iy1 minus x2 minus iy2, where z1 and z2 are two complex numbers taken as x1 plus iy1 minus x2 minus iy2. So these can be separating real part and imaginary part. We have x1 minus x2, x1 minus x2 plus I times y1 minus y2. So its real part is x1 minus x2 and its imaginary part is y1 minus y2. And we know that argument of z1 minus z2, argument of z1 minus z2 will be equal to imaginary part divided by real part. Imaginary part is equal to the real part, and it will give you imaginary part is y1 minus y2 and real part is x1 minus y2. y1 minus y2 divided by x1 minus x2. But argument of z1 minus z2 from the question is given that z1 argument of z1 minus z2 is pi by 4 and argument is nothing but tan theta. Tan theta. Argument is nothing but tan theta. Here argument theta is given as pi by 4. So therefore y1 minus y2 divided by x1 minus x2 will give you tan pi by 4. Tan pi by 4, which is equal to 1. Taking reciprocal of it, x1 minus x2 divided by y1 minus y2 is also 1, because reciprocal of 1 is also 1. By doing this, we wish to use this relation. Where did it? Okay, this relation. We want to use this relation. So 2 times x1 minus x2 here is not available. So multiplying both sides by 2. 2 twice x1 minus x2 divided by y1 minus y2 will give you equal to 2. And this is the relation, and this is the required imaginary part of z1 plus z2. Imaginary part of z1 plus z2 is 2, which is equal to imaginary part. Therefore, our option 3 is correct. Therefore, option 3 is correct. Option 3 is correct. Imaginary z1 minus z1 plus z2. Imaginary part of z1 plus z2 is equal to 2. So, this option 2 is true. I hope that you will like it. Thank you for watching. I hope that it will be helpful for you. Like it, share it with friends. I will meet you with a new video next day. Till then, take care and bye.